Hello, today I'm going to be doing an RStudio demonstration. My name is Diane Parr and I am the Data Applications Librarian. I mostly help researchers with data cleaning, data analysis, and data visualizations using various applications. I also help with troubleshooting coding errors and general data applications questions. Our objectives for today are to provide a brief overview of R and RStudio, show how to load data, calculate summary statistics, create some basic data visualizations, briefly go over some data cleaning methods, and perform some basic analysis. What I do not expect is for you to have a complete understanding of R and RStudio, or to even replicate what you see today. My hope is for you to get a sense of how to use R and RStudio and why using applications like RStudio are useful for your research. R offers the ability to perform complex statistical analyses with just a few lines of code. With R, researchers can document their workflow, share scripts, and ensure that analyses can be replicated by others. R has a large and active community, so it's not too difficult to find help resources online. Both R and RStudio are open source, which means they are free to use and continuously improved by the community. RStudio integrates well with other tools and languages such as Python, SQL, and Git. At the bottom of the screen here, I have provided a link for downloading R and RStudio. First, we are going to pull up RStudio and open our file. So we'll go to the File menu, select that, and we're going to select Open File, and then we're going to navigate to our file for today. Here we are. Select that. Here we are. So let's talk a little bit about what we are seeing here. RStudio is divided into 4 panes. In the top left, we have the source pane. This is where we will type our code. In the top right, we have the environment pane. This is where RStudio displays all of our data sets and variables. We can also import data sets here with the wizard, but I'm going to show you how to do it with code, which is what I recommend just for reproducibility. In the bottom left, we have the console pane, and this is what R looks like without RStudio. You can also code in here, but it won't save in our file, so we won't be doing that. And finally, in the bottom right, we have the Files pane. Here we can see the contents of our current working directory, which is just the file path or folder where we keep all of our R files and data files and the like. This is where our plots will show up. We can see packages that we have loaded into R here, and this is one way to access the help documentation. So let's get started. We're going to start with loading the libraries that we will be using for this analysis. We will be using the library function and put the name of the library that we want in quotation marks. The only library that we'll be using today is the Tidyverse library. This library houses the functions that we will be using to clean our data. So we will highlight this and select Run. Down here in the console pane, we can see a few warning messages, but we can ignore those. R is just letting us know what version of R this package was built under. Next, we will be loading our data set. We are going to name it our data set. We're going to use the assignment operator to assign our data to the name. We're going to use the read.csv function to read in our data. We have the name of our file in quotation marks as our first argument for our function, followed by the header argument, which we will assign the value of true, since our first row of our data is just the names of the columns. And lastly is the NA.strings argument, which we will assign to the value of NA. This is just a way of telling RStudio that when it is loading our data, if it comes across any missing values, you should interpret those as NA. So now we will highlight this code and run it. All right, now we see our data set in the data pane, in the environment pane. We see that there are 200,048 observations, which are the rows, and 17 variables, which are the columns in our data set. So if we select this arrow right next to the name, we can see the names of all of our variables, what data type the variables were imported as, and a few of the first few elements of these variables. Now, if we select the name of our data set right here, R opens a new tab in the source pane. Here we can see a tabular view of our data. So let's talk a little bit about this data set. This is the electric vehicle population data set found on data.gov. It shows the battery electric vehicles and plug-in electric vehicles that were registered in Washington State at the time this data set was published. The first variable is the first 10 of the VIN of the registered vehicles. The next is the county, and then city, state, postal code, model year, make, model, electric vehicle type. This is whether or not the vehicle can be categorized as a clean alternative fuel vehicle, which is based on fuel requirement and electric only range. And then we have electric range, base MSRP, legislative district, Department of Licensing ID number, vehicle location, electric utility, and finally 2020 census tract. So we can already see some zeros in electric range and base MSRP that might need to be taken care of during our data cleaning process. So let's go ahead and get started with that. I'm going to close out this dataset tab and move on to our data cleaning section. So we're going to start with renaming our data set to our data set clean. This way we can preserve our original data set. Next, we are going to use the summary function to get a look at the summary statistics of our data set. So we'll highlight that and run it. Now, we go down to our console pane and we see that most of our variables have the character type. Now for our numeric data type variables, we can see the min, first quartile, median, mean, third quartile, max, and whether or not the variable has any missing values. We see that postal code, legislative district, and the 2020 census tract all have missing values denoted by NAs. So let's take care of those first. Now there are many ways of dealing with missing data. We could have an entire class section discussing just this. For our purposes, let's say we've decided to delete all of our observations or rows with missing values. To do this, we will use the na.omit function. So we will run this. On line 28, I have included the code to search for any missing values and replace them with 0. I just wanted to include this code for you so you can see a different approach for dealing with missing values. Now we are going to clean up some of the variable names and values. We'll start with renaming the variable clean.alternative.fuel.vehicle.eligibility to CAFV.eligibility by using the rename function available in the tidyverse package. So we're going to select the arrow next to our dataset clean in the environment pane. And then let's highlight lines 32 and 33 and run those. Now, we can see the name of the variable has changed. Let's check the number of unique elements in this variable using the unique function. We'll run that. And we can see down here in the console that there are only 3 unique elements in this variable. Clean alternative fuel vehicle eligible. Eligibility unknown as battery range has not been researched, and not eligible due to low battery range. Let's rename those as eligible, unknown eligibility, and not eligible, respectively. So we're going to be using the mutate function that's available in the tidyverse package and the str replace all function from the tidyverse package as well. So we'll highlight all of this together and run that. And then we can see in the environment pane that those changes have been made. Now let's rename the electric.vehicle.type variable to EVT. And we'll also check the number of unique elements in this vector. We'll be using the same functions as above. So let's highlight lines 52 through 56 and run all of that at once. We can see the variable name change in the environment pane to EVT and the unique elements in the console pane. Here we have the elements battery electric vehicle, BEV, and plug-in hybrid electric vehicle, PHEV. So let's shorten both of those to BEV and PHEV respectively. Since we only have 2 names to change, we will use the mutate and the if-else functions. What we are doing with the if-else function is saying if a value in the EVT vector equals exactly battery electric vehicle BEV, we're going to change that to BEV. Then, for all other cases, no matter what they are named, change them to PHEV. So let's run that. And once again, we can see our changes in the environment pane. Now, let's fix some of the data types of our variables. We see that a lot of our variables were imported as the character data type, but many of them are actually factors. Now, factors are a type of categorical variable that have levels, which are the unique values that the factor can take. We are going to create a vector named factor variables and use the combine function to populate that vector with the names of the columns in our data set that we want to convert to factors, which are county, city, state, postal code, model year, make, model, EVT, CAFV.eligibility, legislative.district, and electric.utility. Now we're going to use the lapply function to do this. But before we run this code, I want to show you a way to access a help file from the source pane. So if you put a question mark followed directly by the name of the function you want the help entry for, and run that, in the Files pane, we can see the Help tab for the information we requested. So if we scroll down, we can read the description, usage, arguments, details, value, note, references, see also, and importantly, examples. So let's go back to the source pane and run lines 67 through 70. Now we can see in the environment pane that the data types of those variables have been changed to factors. Right through there. So finally, let's run the summary function again to see if we missed anything. Now we can see a lot more information about our factor variables. We can see counts of the top few elements in all of our factor variables. And we don't see any more NAs. So for now, we are satisfied that our data has been cleaned, and we are ready to move on to some exploratory data analysis. Exploratory data analysis allows us to have a better understanding of our data before making any assumptions. We can identify patterns, detect outliers, and discover possible relationships between variables. We're going to start our exploratory analysis with looking at a bar plot of model year variable. For these visualizations, we will be using the ggplot function from the ggplot2 package that's a part of the tidyverse package. And then we're going to use the geombar function with our data set as the first argument and the aesthetic mapping as the second argument. And here we will specify our variable for the bar chart. So let's run that. And we will go down here to the Plots tab of the Files pane, and we'll select Zoom. We can get a better look at our plot. Now, we see that we have many more 2023 models registered in Washington than any other year, followed by 2022, 2024, and then 2021. Let's say that now we are curious to see out of each year the CAFV eligibility of the registered vehicles. So let's close our plot window and run lines 91 through 92, where we have the same code, but we've added in this fill argument in the aesthetic function with the name of the variable to color inside of all of our bars. We'll zoom in on this one. So now we see that all of the unknown CAFV eligibility vehicles are from model years 2021 to 2024. So for our analysis, we might want to speculate as to why this is the case. We might suspect that due to the newness of the vehicle, some of the variables used to determine the eligibility of the vehicle are unknown. Otherwise, for the most part, we can see that for each model year, most of the registered vehicles are CAFV eligible. For 2021 and 2022, right up here, it's visually difficult to determine whether or not there are more eligible vehicles than not. Now let's close this plot and create a bar plot of electric vehicle type. So our code is very similar to our first bar plot with the aesthetic mapping variable changed to EVT. Let's run that. Let's have a look. So here we can see there are significantly more battery electric vehicles than plug-in hybrid ones. Let's go back to our code. Add in a fill by CAFV.eligibility again. So we'll run that. Take a look. Now, we see that most battery electric vehicles have unknown CAFV eligibility, with the remaining being eligible. And we have what looks like a 50-50 split between not eligible and eligible vehicles that are plug-in hybrids. Let's close this and take a look at some histograms. Now, our only real change in the code is changing the geom from geom_bar to geom_histogram. We'll still have our data set and our aesthetic mappings, where we are changing our variable to electric range and keeping the fill at CAFV eligibility. So let's run that. Have a look. So here we see that all of the unknown CAFV eligibility vehicles have an electric range of 0. And we see that the next chunk of vehicles have very low electric range and are not CAFV eligible. All of this makes sense because of the requirements for CAFV eligibility. So we'll close this plot and we'll look at the same plot, but we'll make a change to the fill. I'm going to change that to make. We'll have a look at that. So, while this histogram is very colorful and pretty, it's pretty difficult to distinguish between the different makes. I wanted to show you this plot to show that sometimes the plots we make aren't too useful. So we'll close that one. Now we're going to focus on some exploratory data visualizations with base MSRP. So let's take another look at our summary statistics. But this time we're going to focus on base MSRP. So we see here that the min, first quartile, median, and third quartile are all 0. So we must have an overwhelming number of values entered in as 0. So it's safe to assume that none of these vehicles actually have a manufacturer's suggested retail price of $0. We also have a max of 845,000, which is very high. We will need to note that to see what's going on there. So we're going to remove all of the observations where base MSRP is 0. And we are going to do that with the filter function, where the first argument is the name of our data set, and the second argument is a logical statement that tells R we only want the observations where base MSRP is greater than 0. So we'll run that, and now we'll look at the environment pane, and we'll see that our number of observations has decreased dramatically to 3,311. That is still plenty of observations for the remainder of our analysis. So let's have another look at our summary statistics. Now, base MSRP looks a lot more reasonable, as does electric range. So let's take a look at the histogram of base MSRP. We'll use the same code as above, but change our aesthetic mapping to base MSRP. So we'll run that and take a look. So we see a very skewed distribution here. It's a very long tail. Now let's look at some box plots to see if we can visually see any correlations between base MSRP and the other variables. This also allows us to see if we have any possible outliers, as we might suspect given the histogram. First, we are going to do a box plot of just our base.msrp variable. The code is very similar as above, but we are changing our geom to geom_boxplot. So let's run that. Here we see 2 points that could indicate possible outliers. Now, sometimes analysts will remove outliers, but we're going to leave our possible outliers alone and continue with our analysis. Next, we are going to create a box plot of base MSRP and county. We'll run those lines and have a look. Here we see some more points of possible outliers. But all of the boxes are pretty much all in the same area. There doesn't appear to be very much variability in the counties. So let's move on to our next plot. This time we are creating a box plot of base MSRP and legislative.district. So we'll run that and open our plot. So here we have almost the exact same plot as the last, which isn't too surprising. There is probably a lot of overlap between counties and legislative districts. We do see a few more possible outliers, but overall nothing too dramatic. So let's move on. Our next box plot is of base MSRP and model. Let's run that. So here we see a lot of lines instead of boxes. This tells us that there is very little to no variability of base MSRP in these models, except for the Roadster. It may be the case that these models don't have very many packages to change the base MSRP. And we do see our lonely outlier out here, and that's pretty much all we see here. So let's take a look at one more plot. Let's look at a scatter plot of base MSRP and electric range. Once again, the code is very similar above, but we are changing our geom to geom point. So let's run that. Now, I don't really see much of a relationship between base MSRP and electric range. There might be a stronger relationship if we remove this outlier that's way out here, but I don't really see any kind of pattern. So let's go back to our code and move on to our final section for the day, and that is analysis. We're going to start with checking to see if there's a correlation between base MSRP and electric range. Based on the scatter plot we just looked at, there isn't an apparent correlation, but we will run the COR function to check. So for the COR function, our only 2 arguments are the variables we are using. So we'll run this, and then we'll check the console pane. We have a value of approximately 0.41. which is a positive moderate association. So let's look at a simple linear regression to see how good electric range is at predicting base MSRP. If we run line 157 for the help file for the LM function, we'll come up down here in the files pane. So here you can review the description and usage and so on about the linear model function. Now we'll go over the code. So First, we will name our model, and followed by the assignment operator. And then we have our linear model function. So the first argument we have is our dependent variable base.msrp with a tilde followed by our independent variable electric range, with the second argument being the name of our data set. So we'll run that. And then we're going to run the summary function with the name of our model as the argument. And we're going to see our output in the console pane. First is just listing out our model. The second section is residuals. Now this last section has what we are looking for. Here we see two rows. The intercept and electric range are independent variable. And 4 columns: estimate, standard error, t-value or test statistic, and this, which is just our p-value. So we are interested in the electric range row. We have an estimate of 103.504, which would be the slope of our linear model equation. The estimate for the intercept here would be the intercept for that equation. We have a standard error of 4.007, and the test statistic is 25.83, all of which gives us our p-value, which is highly significant, especially at an alpha level of 0.05. So all of this seems great, but if we look down low, we see our R² value of just 0.167 and adjusted R² value of 0.1676, which is pretty low. So the proportion of the total variation in base MSRP explained by electric range is 0.17, or only 17% of the total variation in base MSRP is explained by electric range. This relationship might not be linear. It might be more advantageous to try a different model. We could also remove any perceived outliers and run the model again. Or, and this is what I would do, we can try to find all of the actual values that had been entered in as zeros in the electric range and base MSRP variables. We went from 200,048 observations to 3,311, which is a huge jump. It would be nice to try this analysis again with some more observations. So in my opinion, we should go back to the data gathering phase of our analysis and then do this all over again to see if anything changes. Here's a short list of some resources for learning R. There are many options online. Please also feel free to reach out to me with any questions. I'm happy to help in whatever way I can. These are links to the Research Data Librarian Isaac Wink's LibGuide and my Data Applications LibGuide. Thank you for your time.